Hey there, this is MathCamp321 and we're going to do number 10 from your packet, which is an example of implicit differentiation. So in this problem, they give us the natural log of xy plus 5x is equal to 30. Now it's been a while since we've done implicit differentiation, so you're going to want to really pay attention. So I'm going to start with our first term, which is the natural log of xy. Now when I take the derivative of a natural log expression, the argument, or in this case xy, is going to end up in the denominator. But then I want to take the derivative of this argument and place it in the numerator. And the derivative of a product is going to, of course, require the product rule. So it's going to be the first, or x, times the derivative of the second, and the second factor is y. And if I take the derivative of y with respect to x, I get dy dx, or y prime. So we have the first times the derivative of the second plus the second times the derivative of the first. So we've effectively now taken the derivative of the first term. So let's move to the second term. The derivative of 5x is just 5, so that's actually pretty easy. And now we'll travel to the last term, which is 30. And the derivative of a constant is just going to be 0. Now my objective when I'm done with this is to isolate y prime. I need to find the derivative. And that's revealed to us right here in this big complicated expression. So my next objective is going to be to start peeling things away and trying to really isolate that y prime. I'm going to start by moving the 5 to the other side. And I'm going to go ahead and put that negative 5 over 1. So the next thing that I'm going to do is cross multiply. My next step will be to subtract y from both sides. And I'm running out of space, so I'm going to come up here. My last step in isolating y prime will be to divide by x. So we've now found the derivative using what's called implicit differentiation. Hey there, this is MathCamp321 and we're about to do number 11 from our packet. This question asks us to write the equation of the line tangent to the graph of this logarithmic expression at the point 0, 4, use point slope form. So remember, when you have a question about a tangent line, there are two key ingredients that you need to have. You need to know a point and you need to know the slope at that point. Now for this particular problem, they give us the point, and the point is 0, 4. What we don't have is the slope, and to find the slope, I'm going to need to find the derivative. So let's seek out the derivative of this expression. And I think my strategy here is just to travel down the expression from term to term. Let's start with 4. 4 is a constant, and its derivative is just going to be 0. Now let's go to x squared. The derivative of x squared is quite simply 2x. Now let's take the derivative of this natural log expression. We know from prior slides that in finding the derivative of a natural log expression, the argument goes in the denominator and its derivative goes in the numerator. And the derivative of 1/2 x plus 1 is simply going to be 1/2. So rewriting this a little bit more simply, we have the derivative is negative 2x minus 1/2 over 1/2 x plus 1. Now I could probably write that even more simply, but I really don't care because all I need to do is evaluate this derivative at the point x equals 0. And what this means is I'm going to replace every occurrence of x with 0. Now when you multiply something by 0, it essentially goes away, so this is going to go away and this is going to go away. So in the end, what I'm really left with is that the derivative at the point x equals 0 is simply going to be negative 1/2. So now I have the slope at the point, and it's going to be negative 1/2, and I can finish the question using point slope form. So it's going to be y minus 4 equals negative 1/2 x minus 0.